Now I will try to solve the minimum window substring problem. Given a string S and a string T, find the minimum window in S, which will contain all the characters in T in time incapacity big O n. Example: input S equal to T equal to output Note: there is no such window in S that covers all characters in T that we will return empty string. If there is such window, you are guaranteed that there will always be only one unique minimum window in S. I think it's a classic problem which will use the sliding window technique. What is the sliding window technique? Basically, it's similar to the two pointers technique, which we will. At first, we use 2 pointers, low and high, and at the very beginning, the high and the low are both at index 0, and we move high forward to find a valid window, and then we move low forward to get a minimum valid window. So basically, it's the idea. Okay, let's do it. First, we will do some edge case check. If if S equal to none, or S dot length equal to 0, which means we will never find any window, so we just return empty string. And then we need a map to get each character's frequency. But this problem only have ASCII code, so we can use an int array. But if we have other characters, you can use a hash map. In this case, we can just use 128 size array. New int 128, and then we iterate in the string t to get the frequency of the characters to char array. Yes, the map C++. Okay, now we get the frequency. Let me think how many variables do we need. First, we need a count. Why? We want to see such as t length equal to 5, then we should find the 4 characters. So the characters should be the length. When the counter variable equal to t, we know that we have found a window, right? Initially, the count equal to 0. We also need a minimum length to keep the let us know that now we have a minimum length of window. The firstly, it will be initiative like integer max value, and we also need 2 variables, which is minimum start -1 and minimum end equal to -1. Because if they are still -1, at the end we should find the empty string. Do not forget that. Okay. And we need a 2 pointer, low equal to 0, high equal to 0. Okay. For high equal to 0, high less than S dot length, high ++. Okay. Let me first check if the char at high is larger than 0, which means our count should ++, because it occurs in the T, right? And we do the same thing for every char at here. It's to minus. Okay. In what case should we do other operations is if the count now equal to t dot length, which means you already have all the characters in this window. But the low, the low character may be our valid window or may not be our valid window. So we should move the low forward, and that it stay at the index that belong to the string t. So But every time we do the forward thing, we should make sure the index are valid. So we should do low less than high and map s char at low less than 0, which means they have no use, right? We make the s char at low minus, oh no, it's plus because they are negative and they are useless. Make low plus, and then after this loop we make sure that low is now at the usable place, and high is also the usable place. So let's compare. If minimum length is larger than high minus low plus 1, which means this is much less than minimum length will be high minus low plus 1, and the minimum start will be the low, and the minimum end will be the high plus 1. Why do I need to plus 1? Because finally I want to use substring, so substring is exclusive the end index, so I use minus 1. But if you do not minus 1, you can add 1 at the in the end. Okay, and now we already get the minimum valid window ended in the high index. So we should move we should change the char at low plus and move low forward, and the count should minus, because in this case we lose a valuable character. We should try to find it in the next step. Okay, and finally we should check if minimum start equal to -1. If yes, we haven't found any variable, so we just return empty string. If not, we will return s.substring minimum start and the minimum end. Okay, I think it's right. It's edges check, and we always should make sure when we compare or move low forward, we should make sure the index is right. So low less than high is right, and yeah, the larger than is maximum value. Yeah, it's right. And then we change the count. Yes, it's count equal to 10 length. So I think it's right. Let's see. Yeah. Okay, that's all. Thank you for watching.